Hi there, this is Phil Simborg for the USBGF with a recube problem. One of my students sent this to me, and this is a money game, but it could just as easily be a match at a normal match score, say 11 away, or 7 away, and we're trying to figure out the proper cube action here. Red is on roll and holds a 2 cube. Should red double? And if red doubles, should white take or drop? In case you have trouble seeing the race, the pip count is white has 95 and red has 80. What would you do? Okay, if you're like most people, including the student that sent this to me, you double and you drop like a rock. It looks like red's going to get by, and it looks like if red doesn't get by, he's not likely to get hit, and it looks like that if he doesn't get hit or if he gets by, he's way ahead in the race and he's going to win. The truth is, it's a take. And how do we know it's a take? Well, everything in backgammon is math. The first thing you always need to consider is what is the take point and price of gammons. Well, at a normal match score, even on a recube, take points around 21.5%. And in a money game, that's about right. 25 is what you need to break even. But when the cube is live, because you have the power of holding the cube and the ability to redouble, you have a take point of about 21.5%. There's about 3.5% what they call cube vig, or the value of holding the cube. And the value of holding the cube here is pretty strong. If white hits red or gets well ahead in the race, if he misses, he can certainly use the cube to win the game. So let's figure out, how do we determine whether or not white has a take? Well, we need to figure out if white can win this game at least 21.5% of the time. I happen to know that there are 36 possible rolls of the dice, and 9 out of 36 is about 25%. So we need to win about 8 rolls out of 36 rolls. That's one way to do it. You can do it by percentages or rolls. I do both depending on the position, and which is easier mathematically to do in my head. Well, let's figure out how often white can win this game with a shot. How many rolls, first of all, does red not get by? I know this because this is such a common position, but if you start counting the rolls that don't get by, I would start with the lowest number and go up. No matter when you count, if you don't know exactly the number, I recommend you either start with double 6 and work down, or start with double 1 and work up, depending on the position. But go through every roll, that way you're not likely to miss. So I start with double 1, that doesn't get by, then 1 2 doesn't, and 1 3 doesn't, and 1 4, and 1 5 doesn't. The only one that gets by is a 1 6. Well, there's 11 ones, and 1 6 and 6 1 is 2 of them. So there's 9 rolls with a 1 in it that don't get by. Then I go to 2s. I start with double 2. It gets by. Nope, I'm sorry. Double 2 doesn't get by, does it? How about 6 2? Gets by. 5 2 gets by. 4 2 doesn't. 3 2 doesn't. And we already said 2 2, and 2 1 doesn't. So you add the 2s, and then you go to the 3s. Double 3 doesn't get by. And all of the 3s that are higher than, we already counted 3 2 and 3 1, so we go to 3 4, 3 5, and 3 6, all get by. Then we go to the 4s. All the 4s get by, because we're only going to go up from there. 4 5 and 4 6 get by, and double 4 gets by. Then we go to the 5s. All the 5s get by that we haven't counted. 5 5 and 5 6. Then we go to the 6s. All the high 6s get by except for double 6. So if you count on your fingers, or however you want to do it, you'll come up with 16 rolls that don't get by. 16 rolls don't get by. How often will that get hit? Well, most of the time he's going to move. Unless he rolls double six, red's going to move closer. If he rolls double threes, he comes to here and he has to stop. With just about everything else, he's going to get to at least here or here. So at the very worst case scenario, red gets to here, and white will hit 11 out of 36 times, which is about 30% of the time. But sometimes he's going to have a shot from here, sometimes from here, and 1 out of 36 times he's going to get a shot here, which is 17 numbers. So it's hard to say exactly what the percentage of times he's going to get shots, but around 35% is a good number to use on an average. It's slightly more than 30% because of the times you get shots here, here, and here. So if you use 35% of 44%, that's about 16% of the time. Well, you should know that every 1 out of 36 is a little under 3%. And so you know you're talking a little bit more than 5 rolls at 16%. So call it 5.5 rolls. Well, as I said, we needed to get up to about 8 rolls in order to take, or we needed to get up to 21.5% in order to take. So we only need about another 2.5 rolls, or we need another about 7%. The other way you can do it is strictly with percentages. You're going to leave a shot 44% of the time. You're going to hit it 35% of the time. That's about 16%. We need a total of 22% to take. We need to find about another 6%. Is there another 6% chance of white winning the race if he doesn't hit? Okay, so he's hitting about 16% of the time. So 84% of the time he's not hitting. And he needs to get another total of about 6 or 7% wins total out of that 84%, or he needs to get actually a little bit more than that. He needs probably to get around 9 or 10% of 84% because we've already taken off the 16%. So how do we know how often he would win the race if he doesn't hit? Well, let's pretend there's no hit and see how often you win a race when you're losing 80 to 95. I have a method that I use. Let's just use the Keith count. That's what I generally use in a race when the checkers aren't inside. When they're inside, often EPC will help me, and often just counting rolls helps. But in longer races like this, I use the Keith count. And I've got a formula for the Keith count that pretty well helps me come up with a percentage. So when you do the Keith count, you take the pip count of the leader, and in this case it's 80, and you adjust for any wastage or adjustment for extra checkers on the 1, 2, or 3 point, or openings on the 4, 5, or 6, and in this case there's no adjustments. So we have 80, and we divide that by 7. 7 goes into 80 11 times. We add 11 to his pip count. That's 91. By the way, I put a finger on the 9 and a finger on the 1 to help me remember that, so I know that I have 91 for red. What does white have? White has 95. If you count the pips, he has 95. He does have an adjustment for an extra checker on the 2 point. It's 90, so that's 96. 91 to 96. The difference is 5. Red is under by 5. Well, I know that if red was over by 2 after the adjustment, that white would have 22% winning chances. And I know how to adjust for each pip. I've got a formula for that. I'll show it to you. Here's my Keith count notes, and it says that for every pip between the 20 and 30%, you take off 2%. When it gets down below that, you take off 1.5% for each pip difference. So I'm going to use that formula to come up with an estimated winning percentage based on the race. Let's go back to the position. The difference is minus 5 instead of plus 2. So for the first pip, we have 7 to make up, because over by 2, he has 22%. So we take off 1, and that brings him down to 20% because we take off 2% for the first one. And now we still have 6 more to deal with, 6 more pips to deal with. And according to the formula, those 6 pips are worth 1.5% each. 6 times 1.5% is 9. So I take 9 more off of the 20%, and that means that if there's not a hit, that white can win this race about 11% of the time. Actually, I know he's going to win it a little bit more than 11% of the time, because there's one roll that red can't possibly use in this race, where he rolls a 0, and that's double 6. We take away his very, very biggest roll. So let's say that white wins, say, 12 or 13% of the time in the race. So that's 12% of the remaining 84% where there's not a hit. And so that's got to be, what, that's a total of about 9 or 10% more winning chances from the race. Well, we only needed to pick up about 7% winning chances from the race in order to come up to our 22%. So we must have a take, and we must be a little bit better than 22%. We must be around 25 or 26%, somewhere in that range. So if we have 25 or 26% winning chances, then it's easy. It's got to be an easy take. Let's see what Extreme Gammon says. 26.75. Hooray! Plus the fact that he's got cube vig on top of that. The cube vig isn't worth much if he hits, because it's not a very efficient cube. If he hits, the game's over. He just redoubles, and it's over, and it's a big drop. But in the racing situation, that cube has real value, because he could get lucky and roll double 6s, double 5s, roll some high numbers, get close in the race, and get to a point where he has what they call an efficient recube. So he really does have well over enough to take, and as a result, it's a pretty big error to drop this cube. Now, the numbers that I just gave you, if you've never done numbers like this before, if you've never done an exercise like this before, I am sure you got lost a little bit and it got complicated. The nice thing is this is a recording. You can play it back 10 times and make notes. But what did I tell you that you didn't know? That's what you know now need to learn. You don't know what you don't know is one of my favorite sayings. If you don't know how to do the Keith count, and you don't know how to adjust for distribution, and you don't know that you should be adding 1/7, and you don't know how to adjust to come up with a winning percentage, then now you know you need to learn the Keith count. And if you don't know how to count shots and figure out what percentage of the time that red gets by and red gets hit, then you know you need to learn that. These are all basics. But if you know all those things and you still can't do this, and you say this math is too complicated, I want to tell you I'm no math genius, and I learned how to do it. Just practice. Do it a bunch of times. Do positions like this. Change the position where red now is here and see if it's a take. Change the position to where the pip count is different. Give white a much stronger race and red a much worse race, and find out if that makes it not even a double. There are positions here where it might not even be a double. Then figure out the same cube action at different scores where the take points are different. This is at 3 away, 3 away. What's your take point? Make it an initial cube on 3 away, 3 away. This is very close. The take point's 25%. By the way, I assume there were no gammons here in all those calculations. That's a wrong assumption. There's a small number of gammons. It's just a little bit, but look who wins the gammons. It's white, not red. Red's not going to win any gammons in this game if he gets by, to speak of. So it shows almost no gammons for him. So that's another reason for white to take, is he's got an increased equity by winning gammons. When he gets the shot and hits, he'll win some gammons. He's not going to redouble immediately. He's going to see how it goes. He'll only redouble if he gets into trouble or gets into a position where he might leave a shot. So if you know your backgammon and know how to do this stuff, maybe this showed you a little bit more about how to come to a decision in a position like this. And if you didn't know any of the things that I was doing or why I was doing them, now you know where you need to do more study. But if nothing else, one thing you might have learned is that backgammon is math. And backgammon is not just luck and making wild guesses. You make good decisions by calculating your odds. And of of course, how do we know this is a double? We just found out that it's a take. I use Woolsey's law, and once I decide that he's taking, then I decide how many market losers I have. Well, you've lost your market if you get buy. There's 16 times where you don't get buy, and there's 20 times where you do. So I've lost my market all 20 times I get buy, and I've also lost my market if I leave a shot and don't get hit. Well, again, that's a lot of market losers. It's not entirely true. You could leave a shot, not get hit, and white could roll double 6 or double 5 and still be taking the cube. But again, it's well over the 25% market losers that you need in order to give the cube, according to O'Hagan's law of market losers, which is my Bible on whether or not to give the cube. So giving the cube here was pretty easy. The take was the hard part. And doing all these calculations is actually not that hard. It's actually pretty easy once you do it enough times and practice. Hope this was helpful to you. Hope to give you some insights. And thanks for your support of the USBGF. Thanks for watching. Bye-bye.